Hi everyone, welcome back. In this video, we are going to build the SQL foundation required for performance engineering in D365FO. Now, many X++ developers work with queries every day. We write select statements, joins, filters, exists joins, and data source queries. But to truly optimize performance, we must understand the SQL concepts behind those operations. Because every X++ query eventually becomes an SQL query. So in this video, we'll cover the most important SQL fundamentals every D365FO developer should understand before moving deeper into optimization. Let's start with the most basic operation, selection. Selection simply means retrieving data from a table. In SQL, we use the select statement. For example, selecting all records from cust table. Similarly, in X++, we use a select statement or while select loop. Now, although the syntax looks different, both operations are doing the same thing underneath. They are requesting data from the database. Next comes filtering. Filtering means reducing the amount of data retrieved from the database. This is extremely important for performance. Instead of reading all records, we use where conditions to retrieve only the required rows. For example, retrieving a specific customer using account num. The better your filtering, the less unnecessary data SQL Server needs to process. And fewer rows usually means better performance. Sorting. Sorting controls the order of the returned data. In SQL, we use order by. In X++, we use order by in the select statement. Now, sorting may seem simple, but it can significantly affect performance. If SQL Server cannot use an index for sorting, it may need additional memory and processing. So even sorting operations should be designed carefully in large systems. Grouping is used when we want summarized or aggregated data. For example, counting records, calculating totals, or grouping sales by currency. In SQL, this is done using group by. Grouping operations are very common in reports, dashboards, and analytics. And depending on table size, grouping can become expensive if indexes are not designed properly. First only and top one. One very important optimization concept is retrieving only the required records. Sometimes developers write queries that fetch thousands of rows when they actually need only one. In SQL, we use top one. In X++, we use first only. This tells SQL Server to stop searching once the first matching record is found, and that can significantly reduce I/O and execution cost. Now let's move into joins. An inner join returns only matching records between two tables. For example, matching sales table records with corresponding customers from cust table. If no matching customer exists, the row is not returned. Inner joins are one of the most commonly used SQL operations in ERP systems, and join performance heavily depends on indexes and filtering. Outer join. Outer join behaves differently. Here, records are returned even if matching data does not exist in the second table. For example, a sales order may still appear even if related customer data is missing. Outer joins are useful when optional relationships exist, but they can sometimes increase execution complexity and should be used carefully. Exists join. Now let's discuss one of the most important concepts in X++ optimization, exists join. This is extremely important to understand properly. In X++, we write exists join. But in actual SQL, there is no direct exists join operation. Instead, the AOS translates exists join into a where exists condition. So internally, SQL Server checks whether matching records exist in another table. And importantly, SQL Server does not retrieve full data from the join table. It only checks for existence. This is why exists joins are often more efficient than traditional joins when we only need validation or filtering behavior. And later in this course, we'll deeply analyze why exists joins can dramatically improve query performance in many scenarios. So the key takeaway from this video is, understanding SQL fundamentals is absolutely critical for writing efficient X++ code. Because performance optimization starts with understanding how SQL retrieves data, how joins behave, how filtering works, and how execution cost is generated. Once you understand these foundations, performance engineering becomes much easier and much more predictable. In the next video, we'll go deeper into SQL pages and understand how SQL Server retrieves data efficiently. So, I'll see you in the next video.